2.1. Given the arithmetic series 7 plus 12 plus 17, 2.1.1, determine the value of T91. So in order to do that, we need to find the general formula. A is the same as T1, which is equals to 7. And then D is the difference between your terms. So that's a 12 minus 7. It's going to be a 5. So Tn should be given by 7 plus n minus 1 times 5. In order to find T91, we just substitute the value of n. So I'm getting 457. 2.1.2, calculate the sum of the 91 terms. So Sn should be equals to n over 2, 2a plus n minus 1 multiplied by d. That's the formula to calculate the sum of an arithmetic series. 91 over 2, 2 into 7, 91 minus 1 times 5. So I'm getting 21112. 2.1.3, calculates the value of n for which Tn is equals to. So Tn is given by 7, n minus 1 multiplied by 5. So that's 517, which is equals to 7 plus 5n minus 5. 515 should be equals to 5n. Therefore, n should be equals to 107. It's 103. 2.2. The following information is given about a quadratic number pattern. T1 is 3, T2 minus T1 is 9, T3 minus T2 is equals to 21. Show that T5 is equals to 111. So T1 is 3. And then we know that T2 minus T1 must be a 9. In order to get the value of T2, we need to add 3 plus 9. It's going to give us the following term. So this is going to be a 12. So that when we say 12 minus 3, we must get a 9. And then T3 minus T2 is equals to 21. So we need to get a 21 there. When we take this value there and subtract it with T12, we must get a 21. And 33 minus 21 should be equals to 12. The second common difference remains constant for all of the consecutive terms of this row. So in order to get a 12 here, we must say 21 plus 12, that is going to be a 33. So that when we subtract 33 and 21, we will get a 12. So to get this term here, we add 33 plus 33, which is 66. This must be a 12 as well. 45 minus 33 should be equals to 12. 45. 45 minus 33 must be equals to 12. And then 66 plus 45 is indeed 111. So T5 is equals to 111. Show that the general term of a quadratic pattern is given by that. So 2a must be equals to the second common difference, which is equals to 12. Then a should be equals to 6. 3a plus b should be equals to t2 minus t1. 3 into 6 plus b should be equals to t2 minus t1 is equals to 9. We were given b should be equals to negative 9 because 3 times 6 is 18. Transposing it, that becomes 9 minus 18. A plus b plus c should be equals to t1. A is 6 minus 9 plus c 3. Therefore c should be equals to 6. A, which is 6n squared minus 9n plus 6. Show that the pattern is increasing for all n values is an element of natural numbers. Natural numbers are given by 1, 2, 3, 4, and so forth. Okay. It is important to note that the general formula of a quadratic pattern is exactly like that of a parabola. So the value of a in this instance is greater than 0, which means it will be a concave up graph. So Tn should be equals to 6n squared minus 9n plus 6. Prime, we find the derivative. This is 12n minus 9. And we know that the gradient at the turning point is equals to 0. N should be equals to 3 over 4. So somewhere there, I'm going to have n equals to 3 over 4. So 3 over 4 is the same as 0.75. So we can clearly see that a 1 will be somewhere to the right. So will be a 2, a 3, 4, and so forth. So from this part going up, the value of the gradient is positive. So it means that n is indeed increasing for all natural numbers, because you can see that 3 over 4 is less than 1 from that part going this way. So therefore